Poisson distribution. Poisson is the one of the name statistician. He was French, so it is not a Poisson, it's a Poisson. Okay. Here is a formula. Yeah, it's a totally different. Let me see an example. Let me make bigger. In this example, yeah, absolutely, we have to have some random variable. Now, the random variable is the number of patients who are alive at ER is between 6 and 7, right? Okay, let me ask you. How many text messages do you receive in a day? How many text messages? Guess, please, it's a statistics. Guess, estimate.
30 to 50.
30 to 50? How many?
A lot.
Yeah, a lot. Yeah. Why not?
No.
Mm-hmm. How many?
100 maybe.
100 maybe? You? More than 100 or less than 100? Less than 100?
Probably like
80?
Yeah.
It's not more than 100?
Maybe. Are you talking about like each response that we like?
Whatever.
Okay.
Yeah.
More than 100. I don't know.
How many?
More than 100.
More than 100? Whoa. How many friends do you have? You know, it's for me, 2 or 3 messages from my wife. Buy some eggs, milk on the way home, right? Okay, you said it's about 100. Have ever taken more than 100? Someday?
Yeah, probably.
Probably, yeah. How about the more than 200?
I don't know.
You know, probably most of us have an unlimited plan, right? But can you say it is my own limit? For example, you know, usually I have 2 or 3 texts from my wife. Then someday I suggest my wife I do not take no more than 5. It's impossible, right? Yeah, who knows? Usually I have 2 or 3 text messages in a day, but some days more than 100. Maybe on my birthday. Yeah, from many friends. Yeah, who knows? Who knows? More than 200 for me. It's more than 300. It's almost impossible, but anyway. You know, what I want to say, in the Poisson distribution, there is no limit. Please look at this example. What is a random variable? It's a number of patients who are alive at ER. It's between 6 and 7 p.m. And here is the average. The average is about 7 patients in an hour, ER, between 6 and 7, 6.9. That is the mean, average. But think about the number of patients who arrive at the ER. It's not 6 to 7. How about this one? Friday night at 1 a.m. to 2 a.m. Do you expect only 7? Only 6.9 on average? Friday night. How do you think? Is more than 7 or less than 7? More. Yeah, why not? Yeah, Friday night. Drunken. Don't drive. Right? How about Christmas Eve? White Christmas. Snowing. Right? And Eve. Yeah. Don't go outside. Yeah. How many car accidents do you expect in a week in Fort Smith? How many? How many car accidents in a week?
40.
40 in a week, 40? How many do you expect?
Probably like
20, 40? How do you think? At Fayetteville, I mean the Fayetteville, it's not Fort Smith, it's a Fayetteville, a week.
Probably.
It's more than us. Yeah, because there's the bigger, the reason, right? And it's a highway, right? So everybody is crazy, right? Yeah. So, please remind what was the binomial distribution. I gave you an example. Toss one coin 10 times. And the random variable was always the number of, for the discrete random variable. The random variable was the number of heads. When I toss 10 times, can I get 11 heads? Impossible, because I tossed only 10 times. It's up to 10. I couldn't get 11 heads, 12 heads, right? But the number of patients who are alive at ER is between 6 and 7. And I ask you the number of text messages, the number of car accidents. There is no limit. So it's almost the same two random variables. One was the number of heads, and now the number of patients. But the previous one had the limit up to 10. But now we don't have any limit. It's actually, we might think about the possible maximum number of patients. The possible maximum is number of text messages. But it is not easy to say it's up to 10, it's up to 100, it's only up to 200. In this case, we have to use another random variable. It is the Poisson. So look at this. The possible value of x from 0, always from 0. Even in the binomial distribution, when I toss one coin 10 times, what was the smallest possible number of heads? 0. What does it mean? No head. All tails. Tail, 10 tails. So always the discrete random variable begins from 0. But there was limit in the binomial distribution. But now in the Poisson, it does not have any limit. Okay, so that is the big difference. It's going to infinite. And the probability function, it is a totally different. Okay, the very first one is the E function. Yeah, it's any kind of calculator has the E. Yeah, please look for where is your E on your calculator. And the power is the minus. I hate Greek letter. It is a lambda. It is another Greek letter, it's a lambda. Lambda. That is a mean. Like as the N and P in the binomial distribution, the number of independent trials and probability of success, Poisson distribution has only one parameter, that is a lambda, and it is the mean. Okay? The lambda is the mean. So we plugged the lambda in the power, but remember, the power must be negative lambda, the negative the mean. And then take the lambda with the power x. X was one of the value for the random variable, and divided by x factorial. To remember where was the factorial? You can go to the same place on your calculator. For example, TI-84, the number 3 was NCR, and number 4 is the factorial. So at the same place, you can take the factorial. Do you have an idea? So let's do it. Please look at this example. as I told you, for the number of patients, we can use the Poisson distribution, and the lambda was given as 6.9. That is a lambda. That is the average for 1 hour. So now we need the probability. We are going to have exactly 4 patients at ER using the formula. The formula was here, right? So let me copy E minus lambda. The mean was 6.9. And lambda 6.9. And the power was x. How many x now? X equal 4. Now I can say it's x equal 4. So the power will be 4. And then divided by 4 factorial. Just copy the formula and plugged how many lambda, how many x. And now let me take part by part. First, let me take this one, the E part. How much will be the E to the negative 6.9, please?
0.001.
0.00. Can you give me 4 decimal places?
0.0010.
0.0010, thank you. Did you get 0.00? No?
I don't know how to use this calculator. I forgot my other one. So.
Let me check, just a second. Let me check how much will be E to the negative 6.9. Yes, you're right. I have a 0.001008. It's a 0.001. And the second one, how about this one? 6.9 power 4. I have a 2200, 2266.71. Did you get the big number? Finally, divided by 4 factorial. Please plug 4 and go to the math key, probability, and take the factorial. How many? How many 4 factorial? 24. Thank you. So we take 3 terms again and plug into the formula. Finally, how much will be? 0.095. Did you get 0.095? Even though, we had big number there, but finally, who is the 0.095? Finally, it is a probability. Can you remember that? Any kind of probability must be less than 1. Remember, even though we have a huge value here, but it was very small. So multiplication returned less than 1, finally, for the probability. Let me try one more. At most 2. Just a second. At most 2. What does that mean? At most. Before we had at least 1 or 2. At least was, for example, at least 2 was 2 or more. Then what is the at most 2? 2 or less. Okay, so please remember, at most 2 means 2 or less. What is the possible values in Poisson distribution? From 0, 1 to 2, infinite, right? So 2 or less means probability x equals 0, 1, or 2. There are disjoint, mutually exclusive. Oh, do you remember the mutually exclusive? Separated each other, right? Here's a or. We applied special addition rule. Do you remember that? So anyway, it will be same as probability x equals 0, add probability x equal 1 plus probability x equal 2. So we apply the probability function 3 times separately at x equals 0, at x equal 1 and 2, and then sum up. Okay? So let me try. Again, E power negative lambda. Lambda was 6.9 times 6.9, 0, and 0 factorial. Again, E negative 6.9 times 6.9 with the power 1 and 1 factorial. And the last one will be again E negative 6.9 times 6.9 square and 2 factorial. Okay, so simply just plug into the formula when x equals 0, when x equals 1, x equals 2. Then take separately and then add up. Anybody who take the first one? Let me see. I can expect 6.9 with the power 0, it would be 1. Because always with the power 0 will be 1. Anybody who took 0 factorial? You know 0 factorial is not a 0. It is 1, yes. So simply take the e to the negative 6.9. It was 0.0010. So the very first one will be 0.0010 times 1 over 1. So it will be 0.0010. And the next one, is already we took the E part always 0.001. And the second part, 6.9 with the power 1 is itself 6.9. Anybody who take the 1 factorial? 1 factorial will be 1 again. So the second term will be 0.001 times 6.9. So how much will be the second one? 0.069. Am I correct? What is the second one? 0.0069. I'm sorry. 0.0069. And how about the last one? Still, the E part is 0.0010. And 2 factorial is what? 2, thank you. And here is a 6.9 square. Please tell me, how much will be the last term?
0.0234.
0.0234. Anybody? .0234. Then now take the sum, please. 0.032. Another probability. For what? At most 2. 2 or less. 0, 1, or 2. Even though we added 3 probabilities, but it will be another probability. Must be less than 1 again. Remember. It's good? Okay? How about the last one? The last one was here. Between 4 and 10 inclusive. Just a second. I do not try to take the probability because we have to apply the probability function so many times. But we have to understand what do we need. Between 4 and 10 inclusive. What does that mean? So let me erase. So we need the probability 4, 5, 6, 7, 8, 9, and 10, right? But it is the same thing. They are mutually exclusive. We should apply the special addition rule. So we have to take probability x equal 4, 5, 6, 7, 8, 9. Finally, the last one will be 10. So we should apply the probability function, which was x equals small x was e to the negative lambda, lambda x and x factorial. How many times? 1, 2, 3, 4, 5, 6, 7 times. We apply the probability function 7 times and then add up. That would be the probability as between 4 and 10 inclusively. Do you have an idea? I don't want to try that one. Yeah, 7 times is too much. Yeah. It's good?